Right. Just a recap for what we discussed yesterday. We had a basic idea what about the network we are going to learn for what exactly uh, we are talking about. Okay. So we talked about the network, which is a connection of computers or devices to use the resources like documents, email, messaging, website, database, these things we discussed. We also talked about how the entire world is connected through the cables, undersea cables of internet service providers. Then we also discussed there are data centers with is making this communication happening all over the world. Like I'm sitting in a corner of our country, and you are sitting in any corner of the world. My voice is there. My video can be there. Uh, the content that I'm sharing that is there. So this is communication from my computer to your computer. So the ISPs, these cables, these data centers, network devices, the cables that you see in the picture, these devices made it happen. Okay. Also to communication, which is happening, the communication which is there in the entire world, that is governed by the specific rules, which we call protocols. Okay, the protocol is needed to have the communication occur efficiently, and it is vendor independent. There are independent protocols which is making entire world connected. Otherwise, it might happen that I'm using a Dell device. I will only be able to connect with a Dell device, not any other vendor. So there are protocols which are open sourced, which are open to the entire world to use so that the communication is happening between me and all over the world. We also discussed a view introduction that there is a reference model which we will discuss later in this class. These were developed because of different vendor in the market, and there were different manufacturers who were manufacturing the networking devices, which can make the communication happen in the entire world. So to make it vendor independent, the network reference model and shoots of protocol was developed. Also, this network reference model is learned because it makes troubleshooting easy. It makes network engineers to identify the issue, like where exactly that issue is occurring, in which layer is it occurring. So we'll learn this in detail in coming classes. We also discussed the network types, local area network, which can be in a specific area, a small area in a small building. So Ethernet is the common LAN technology. We'll also learn about this. There is a WAN, wide area network, the internet through which we are connecting as of now. This is also a wide area network. It spans large geographical locations. All right. We discussed about these network types, which is man metropolitan area network connecting citywide geographical area, campus area network, the network which is in a campus like school, universities, hospitals. We also discussed about PAN, that this is personal area network, like Bluetooth. Internetwork is a general term, like everybody is connected. The network of networks are called internetwork. So internet is largest internetwork in the world. Network components, we have discussed about these components. Like we will, in CCNA, we will also revolve around these two devices, switch and a router. So if you see at the pictures, the blue picture is the symbol of switch, which we use while learning CCNA. In fact, also if you'll go and work in work in corporate, so when you will see the designs, the switch will be shown in the design as this symbol. Switch provides connectivity to host within the same LAN, so it works on the local area network. The interfaces are more to connect the end host with the switch. So it do not provide connectivity between different LANs or different networks. All right, router again have fewer network interfaces than switches. One second. Okay, sorry. So these are used to provide connectivity between two networks. All right. So we'll definitely learn about these devices in detail. We also discussed about firewalls, which is the lock, which is the security device in our network, which protects attacker to enter into our network or access anything which is inside our network. So we can use that. Servers are the devices with more RAM, more uh, sizes of memories itself. So there are disks which are used in these servers, which can store TBs of data, and it acts about as a server if we have stored any tool or any we have made that device a Outlook or email server or database or file server, anything, so that acts as a server, a computer if it is requesting any information to that device, so that becomes a client. So it works as a client server model. Endpoints are the endpoints which are connected to the switch. So if I'm working on this computer, so this is my endpoint, printer is one endpoint, server is endpoint. So there is nothing connected to that after we connect it to the switch. So that's called endpoint. Examples are endpoint of view. Access point of the device, which makes wired connection to wireless. If we connect access point to a switch which is connected to internet or which is connected to a server, so that access point will make the network as wireless to connect our wireless enabled devices. So we checked these things. We checked devices. So what happens when you work in corporate? Is my screen visible?
Yes, yes, sir.
Yes.
Thank you. All right, so we are talking about Cisco. So Cisco is one of the biggest biggest manufacturer in the network industry. So uh, if we call manufacturer, that would not be a good introduction. So Cisco is a vendor, you can say, which provides multiple services, multiple devices. It has own iOS as well. Okay. So in the network industry, in the communication industry, it makes at most everything. Whatever uh, parts or whatever software it cannot make, so it acquires. Okay. like in the Catalyst switches you have heard about. So it has been acquired. It was a different company. It's Crescent something company was there. It was acquired by Cisco, and then they are selling it as a Cisco Catalyst switches. Okay, there is another company called Viptela, which has been acquired by Cisco. Now Cisco is uh, selling and giving services to of those devices of Cisco Viptela devices, which are SD-WAN platforms. So it's giving services as Cisco Viptela. All right. So when you work in a corporate as a network engineer, so this site is very much helpful. This site is very much helpful to you uh, to get the idea of the devices, what devices are in your network. Okay. So if you want to explore the devices, you can go to cisco.com, then click on support, and you have options, products, and downloads. Okay. You have multiple options: switches, security, routers, wireless devices, unified communications. So this deals with the VoIP, voice over IP. Okay. So earlier it was not possible to like it. There was a telephone call. There was a telephone line to communicate, to send our voices to talk, if we want to talk to someone. So it was telephone lines which were in use. But nowadays it is happening. You have only internet line. You can send your voice. You can talk as a you can talk with anybody connected to the internet. But you should have that VoIP line, voice over IP, which that is called. Okay, that's a separate thing. There are different courses for unified communication. There are collaboration endpoint and phone. It is also described as there are video services, like there are Cisco devices which serves as meeting providers. Like there would be a big TV screen, there would be mic, there would be cameras, and it will be installed in a meeting room. So anybody who is in a remote location, they can have a great meeting experience with that. It also has network software. It also has servers, unified computing system, that is Cisco UCS servers, uh, which which are the which acts as a virtual. So what happens? These are physical like hardware devices. So these servers have like before, what was happening earlier, like for one server, if you have to if you want to have an email server, you needed to get a hardware device that will act as a email server. If you want to have another server which will act as a database, so you will have to purchase another hardware. But unified computing system, this UCS server, what it does is you purchase one hardware UCS, and you install VMware on it. That makes that hardware device a virtual device. So the RAM would be there. A few three portion of RAM would be uh, there for one server. So it makes it virtual. So in one physical hardware device, you will have multiple virtual devices. So one hardware you purchase, you can take like use of it as a multiple servers, multiple virtual servers, right? So if you want to explore switches, you can go to switches. These are the different varieties of switches. It has depends on costs, depends on functions, depends on speed, depends on features, what features you want. All right. So this symbols that you have, the symbols are like end of life is announced. So these will be end of life. Cisco will stop selling these devices in this and that date. So near ended devices, the advanced devices, which are new devices, these are 9400 series, 9500 series, 9600 series. Okay, these devices which have black dots, these devices are end of sale. It is not being sold. These are legacy devices, old devices. So if you want to explore these devices, you can just click on that. You will see that this product is no longer supported by Cisco. End of support date was 19, end of support. So you'll not see these devices. Mostly the organizations, what they do not use the devices which are end of support, because what happens if this device would be, there would be anything uh, uh, with this device, Cisco will not support that. Cisco TAC would not support that. Okay, so they do not risk their network, because what happens if you see, if you have, if this is a end of sale, end of support device, so you have connected, suppose you have connected this device. Suppose you have connected a switch, that end of device switch, to this server. To this server. Like this is end of service. Now, this server is a bank server. Right? And this is connected to internet. Now from here, one of our guys, like I am connected with my computer. I opened a net banking, gave the user ID password. I did a transaction of some amount. Everything is being registered, being taken through this server. All right. So if this is end of sale or end of support, suppose the connection here, the port, it has gone bad. Now the service is down. If the switch itself goes bad, it's not working at all because it's a old switch. Entire services, the bank persons who are connected here with these PCs, workstations, laptops, they're also not able to connect to internet. And this server also has tools what these bank employees use to work here. Like one of the example is that if you go to SBI branch, and sometimes you will hear, sir, the link is down. So what happens at that time? So obviously in practical scenario, the organizations will not install only one server, but they will install a backup server as well. But sometimes it happens like it. This is the main reason if you have end of support. So if this is a new switch, this is not end of support, Cisco TAC will come here, they will troubleshoot. And if it is not fixed, it cannot be fixed, they will RMA. They will replace it within 2 hours, 4 hours, 24 hours, as per the contract of the support that this bank has taken. Like, right? So the link is down. This issue, mostly this server is not able to connect with the network. All right. Am I making sense, guys?
Yes, yes.
Yes, sir.
Thank you. All right. See. So when you explore these devices, you will have multiple things here. You will have, you can expand it. You can have different looks. Like these are the ports. These are the ports where, sorry. These are the ports where the end devices, servers, PCs, these are getting connected. These are the uplink cable, uplink ports where your routers are getting connected, right? You can explore these devices. Okay. You can also get the data sheet. The data sheet, so you will not understand as of now what are the data sheets. So data sheets will have uh, the features, all the features listed, all the features and all the LAN cards, features, everything, what you can do. Like it's kind of it's kind of an introduction of that switch, what exactly that switch will work for, how that switch will work for, how many ports are there, what uplinks it is supported. Okay, so you can explore these things. What is the port number? So here, this is a specific model. If it's a specific model, it will have 24 ports, 48 ports. Power of it, the power on Ethernet. This is also a feature where you don't have to get the power supplies. Okay, so it will get the power from the internet cable it is handling. Right, so that and also the thing is, if you purchase a Cisco switch, so it does not become ready to use. Okay, because that Cisco switch you are purchasing, that is only the hardware. To use it, you will have to get the licenses as well for the ports. How many ports you can use? Everything is there. Everything is written in these data sheet. Okay. Also, this site will have the installation guide is not there for this device because yeah, installation guides would be there in downloads, but it's not there because this is end of support. So you will also get the installation guide. We go back. So you will have series release there. It was released in 2019, end of series 13th of 2024. And end of support in 2030. End of support means if somebody purchased this in within 13th April 2025, so it will not have uh, uh, it cannot they cannot purchase a new this series switch after that. because the support still the support would be there for another 5 years from Cisco support. So that is what is written here. Download. This is the software suite. Installation guide, you see? This is an installation guide for devices, how you will install it. So it will show you what are the ports, what are the buttons there in the device. Do you know, anybody know what is this thing? Console port? Anybody tried it?
Yes, yes. Connected to our
Used for
CA.
the configuration.
Sorry?
Used for the initial configuration.
Initial configuration. So you have used this cable, 9-pin serial port cable.
Yes.
And how did you connect that?
Router to laptop.
Router to laptop? This is, we are talking about this switch.
He means switch to router, switch to laptop.
Switch to laptop. And then what, you were able to get to the console page? Hello? Hello?
Yeah, I think he was having mic issue, maybe.
Okay. So it does not directly connect, the cable is connected to the laptop, obviously, but you will have to use a software called PuTTY to get the console connection to that device. Okay.
Yeah, putty is like to access the Linux of the device.
Yes. Yes. And then you can learn the setup wizard, whatever initial setup you want to do, you can do it. All right, so this is what we are talking about. This is something which is legacy. We used to do it before a few years. Nowadays, there is a new technology where engineers doesn't have to go to every device to do the configuration. Is it do you guys agree with it? After initial configuration, a few years back, what was happening? You need to get to the console of the device every time you need to make any configuration change. So, anybody who can let me know the new technology that we have in today's world, that every time any configuration change we need to make in these devices, we don't have to go to go to the device and connect in the console port. We can do it remotely.
SSH or telnet.
This is also a legacy. SSH and Telnet will be there in only one switches.
I mean the automation on
Centralized thing that we are doing
DNAC,
it.
right? DNAC.
That is also something which cannot do all the configuration, that has limitations. You heard about software defined?
That's DNA, right? Software defined. Yes, DNAC.
Software defined network, SDN. Have you heard about Cisco ACI?
Yes. Yes. Is the data center?
Yeah. Yeah.
NextGen CCNA is the data center
Yes, 9,000 series
networking
is
concepts.
being here. Yeah. So what happens in that? So it has a centralized epics where you can just you can have the GUI and you can push the configuration to the switches. Okay, you can explore. So while going out with the switching and routing, we will do more about this. Like we will learn more about these devices, how that work. So we let's continue to the CCNA thing. One second. Yeah. This is not happening. Right. Alright, so we will now see what exactly the steps. What are the steps to design a new network, a small network that we can design. All right. The first thing, what an engineer does, or a solution architect or a designer does to design a network, it's a site survey. This one. This is like if you are building a home, so you will if you are building a home or any building, so you will go to the plot where it is being built. You will take the you will get the size, like what exactly is the size of that plot, what plotting needs to be done. So this is exactly with that. Whenever there is a network design will be done, a new network will be designed, there would be a site survey. Right. So obviously with CCNA, but we will not be able to get to that team who does the site survey and the things. So, but it's good to know that while designing a network, the first step is site survey. Then it's the design, the blueprint that you get, or you the blueprint or the design that you make of your building from the network from the architect. So this is the case. This is the job of a network architect, the design. So if it's a small office, how many devices it should be connected with? What devices should be connected with? What kind of speed we have? What kind of business it is to take care of through this network? Because everything, whatever it is being done, so that depends on the cost, right? Uh, if you're opening a small office, uh, uh, you will not purchase the high-end devices. Like there would be mid-range devices or small devices to take care of your small business. Also, if you are an enterprise, you will go with the high-end devices. All right. So the design is another step. Implementation with the CCNA, you can definitely get into this team, implementation team. So in corporates, what happens, guys? There would be different person to take care of different job. All right. So you're also, if you're also working in corporates, you will see there are different teams working on the. There is there are teams who are only looking after the protocols. There are teams who are only looking after the hardware issues, like the power supply of the switch is not working. So there would be a different team who is handling it. There would be different team who is only taking care uh, of the troubleshooting on LAN cards. All right. So with this CCNA knowledge, you can definitely go into this implementation team where designer will give you the design, and he will say, if you are in a switching team, he will say that you need to configure this switch. He will give you in the design, he will give you what exactly this switch configuration should be, how many VLANs would be there, right? What SFPs would be like cables would be there, what configurations is needed to connect different end devices. All right. If you go to the wireless team, you will have a job to configure this wireless access point. Or if you are in the support team, like maintenance team, after the configuration has been done, if there would be any issue, you will be the troubleshooter. So in corporate, it happens like this. Okay. After implementation, it will be the next step to secure the network. Security will again depend of the type of business you are doing. If you are a bank, if you are a government organization uh, which has data breach risks, if you are organizations with critical operations like hospitals, so that depends upon the security how your organization works, right? So then you will be using firewalls on that. You'll be using IPS, intrusion prevention systems. There are firewalls with this feature as well. There are different devices as well for this one. So there are multiple things you will do if you are in a security team, network security team. Then it comes with upgradation and troubleshooting. There would be a support team that is called technical support. So when any device is being launched, right? So they have the room to get the features more advanced with the time. Okay. So you have been heard about the upgrades. You come your sorry, your phones are also being upgraded time to time. There are patches which company releases. So that is one task you will do. Troubleshooting part in any of the team, there would be a support team. Like after installation, after implementation, if there are any issues happening, you will the person to support that, to fix that. The TAC team, the best team of any a troubleshooting team is the TAC team. That's the highest level of troubleshooting. TAC team of any, either it is Cisco TAC, Juniper TAC, D-Link TAC, Palo Alto TAC, anyone. So TAC is the best team to troubleshoot because it's the highest point of escalation. So the companies will have its internal network engineers who will work on these switches. If they are not able to fix the issue, it goes to TAC. And if TAC does not attack, do not fix the issue, then it will be replaced. Anyone of you ever worked in TAC or want to work in TAC?
Yeah, I have work with the TAC experience.
You have the TAC experience?
Yes.
Which TAC you were in?
No, I am not a TAG engineer. I am the partner. There is a ticket on the TAG engineer. I am working with the TAG engineer.
Oh, you're working with the TAC engineer.
Yes.
All right. So, you know that TAC engineer has access to everything on customer devices, right?
Yes, correct. Correct. Exactly.
Right, exactly. So why? Why? Because they have trainings of the product. They are mostly the product owners, product specialists. Okay, the Cisco Tech. How? Like I have the experience with Cisco and dealing tech. So in Cisco Tech, what work? How they work is they have a product. Right. If you have a product 2900, so they have a dedicated team for that product. So anything with respect to that product, the engineer will have knowledge. So that is why when the sales team of Cisco sales the support contract to the customers, so they inform them that my engineers have the access to your devices because nowadays it is called there is a called Intersite or something which is in place with Cisco where customers do not open a manual case. It just any issue happens in the device, it comes to the TAC. If I'm correct, like I was there, so it was there, right? So have you heard about Intersite?
No. First time I heard about actually this case through the portal or a telephonic. It has some criteria, right? A critical P1, P2, P3, P4. The SLA,
Yes.
right? P1 is a critical, very, very critical. Within
Uh,
30
within
minutes, the
five
engineer will
minutes,
join.
you
P2, yes,
within five
yes,
minutes is internal Cisco. So for the customer, it is might be 30 minutes because you are going through
yes,
different
correct.
service desk and things, right? So whenever the
Yes,
case
correct.
is built in, so in 5 minutes, Cisco engineer would do the first line engineer would be there on call. For P3, the Cisco engineers will not be on call. They'll send emails and ask for the things. But there are automations in Cisco. There are devices. Maybe you are not you have not experienced that, but there are high-end devices with Cisco. So what happens? The customer is subscribed to a central intersite portal where that device is being monitored with that anything happens that there is a RAM issue or high disk utilization issue, the case is created by itself and it gets assigned to the tech engineer. Tech engineer reaches out to the customer directly. So it's everything. It happened
Oh,
automation. Yeah, it is
oh,
there in the Cisco. Yes.
maybe this scenario is, yeah, this maybe this scenario work on, I think interesting, it work on the bank side, right? Maybe. I'm sorry
Yeah,
if I'm wrong.
there are, yes. No, so I have experience with that. I know that is there with Cisco, but uh, uh, it may happen that Cisco is charging more for those services. So not every customer takes that,
Okay.
right? Yeah. Sorry,
It's very costly, right? Contract.
Cisco is costly. Cisco support is very costly,
Yeah, I have.
very costly. Cisco
Yes, yes.
support is because that is
Which means you are mentioned, right? So could you please repeat again the technical term? Yeah.
intersite,
Okay.
intersite.
Thank you, Mayu.
No problem. So you can Google that. Let me see if it's there or not. It was there. Cisco Intersite. Here it is. You're seeing the screen?
Yes.
This is the one.
Oh, okay, okay. Okay, got it. Thank you.
So there was a big data also, which was yeah, it's still there in Cisco. I have my friends working in Cisco. So big data, what it does is, if you have experience, so earlier what was happening, if there was an issue with Cisco device, the customer had to pull the log from that device and attach it to the case. Are you doing the same?
Yes.
Are you still doing the same?
Yes, still, even no, if suppose P3 means it has some criteria, right? It uploads
Yeah.
tech support file and logs
Hmm.
under the configuration and also.
You have the mic issue. You have an audio issue. So let it be. So I just wanted to inform that there's one more automation thing which is with Cisco, that you have your serial numbers are registered with the devices. So whenever there are any issue, if you're trying to create a manual case, so with that serial number, it will automatically generate the latest tech support files, the logs, and it will attach to the case. So the tech engineer who is getting assigned to it, he can download and get that tech support file analyzed. So that's also automation. So this is the best era of technology. Everything is getting automated. So, all right. Anyone else worked with TAC or want to work with TAC? No?
We haven't worked, but
Yes.
maybe in future.
Yeah, if you get opportunities, I think you'll get the best exposure in this field in TAC itself.
Yeah.
Okay, let's get
One,
right.
one question, sir. Is that possible to cover tag content as well in the CCNP level so that they can learn the tag troubleshooting as well, right?
TAC content is not possible because that Cisco proprietary, nobody can take that. I also don't have the authority to take those material, but we can have the scenario discussed in between, like we did as of now. Uh, the exact scenarios, what exactly the cases are
Yes,
opening.
yes. Same like that,
Yes.
like what scenarios they face,
Content.
how they
Yes.
troubleshoot, right?
Similar content. Yes. Similar content.
That is possible to teach in the session, right?
Yes, that can be done. That can be done. But we are very initial phase.
Right,
In a
right.
very initial phase as of now.
Yeah.
Okay. All right. So this is uh, uh, the steps: site server design, implementation, securing a network upgradation, troubleshooting. But this is very brief what I'm talking to you, because this is a CCNA class. That's an entry level program of a network engineer. Okay. So there are people, there are team. If you see in an organization, if there is a site server team, there are multiple people working to that. There are multiple phases of work. There are multiple parts of work that one person is doing. So that's very complex. You start learning, you upgrade yourself, you upskill yourself, you will get to know each and everything. Okay. So when you see, when you hear about the salaries, that somebody is getting 45, 70, 80 LPAs, all right. So that comes under these two steps. If you are a solution architect, if you are a technical head, you are a site auditor. So these roles are very expensive roles. So, and for CCNA, CCNP with your experience, you can easily get up to here and you upskill yourself, get experience, and you can get to these positions where the payments are, the salaries are very high. Okay. All right. All right. So let's get to the topology. So while in the last slide, while we were doing the site survey, so after that it comes the design, how your network would be, how things would be connected, how end device, how a computer of a person will be connected to a server, right? So these things are there. Although these topologies that we are discussing, these are very these are very brief as of now, and these are not almost practical in the enterprise today. But yes, these are in the syllabus. You will have to get to know the foundation to understand the things in a better way. Okay, so there are topologies which we call which we call it like a design, a blueprint of devices connection. What devices would be there, how those will be connected. You will have to check while designing that. You will have to keep a note that the topology would be should be easy, so that if something breaks down, you have the idea where it actually breaks, where it actually broken. Okay. So the first is bus, then we have star, ring, tree, mesh, and hybrid. Am I connected? Hello?
Yes, you are.
Yes, yes, yes.
All right. I think something is alright, not getting forward. Okay, got it. All right. So this is a very legacy technology you will not find anywhere. Okay. So if you see the bus topology, the design is here. There was a backbone cable. This is called as backbone cable. And this cable was coaxial cable. So I don't know what age group is joined, but when I was a kid, there was a black and white TV in my house, and in that TV there was a cable came which was like this. Anybody in that age group, or I'm the oldest one?
Yeah,
No,
yes.
sir. Yes, sir. Mayur, I'm also seen in the older
Televisions.
Yes,
access
yes.
point or the
Top
coaxial cable.
connection.
Coaxial cable only using.
Yes. So this cable was the thing. What was happening? There was a terminator. This was a terminator which was uh, connected to these cables there, and the cable was a backbone cable. It was there, right? There was some ports which was connected here, 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 and in devices were connected. Okay. Now, when it was connected, if this device wants to communicate with this one, it was easy. It is getting communicated, but the thing was the speed was very less. Obviously, at that time there was no 3G, 5G, 4G, so the speed was 10 Mbps per second. Troubleshooting was not easy. Okay, troubleshooting was not easy in here. Suppose this device is not working. Now you will have to take the whole cable where it is happening, because this was not a duplex communication or something. And the network was very risky. If this cable goes bad, no devices will be able to communicate to each other. Data loss was very much, because everybody was broadcasting. If it is sending a message, it will go to this also, this also, this also, this also, and then will terminate here. And it was also a costly kind of thing, because multiple cables are there. Okay, there would be this coaxial cable. If it's a backbone cable, suppose there are multiple devices connected, so long cable needs to be purchased. And with that, there are various. So this is about bus topology. You will not find anywhere. You just have to have the idea about what was it. Then came star topology. So star topology, what it was, right? So there was a centralized device. It's written as hub. Everybody, I think, knows about the hub. We had already also discussed yesterday. Hub was a switch-like device. Okay, but this was not intelligent. You can simply call it as a connector. Devices like this. It has ports. One device is connected to here. Other is here. You send the data, it will send to everyone. That's it. It will not do anything. So after that, the intelligent device came. It called switch. It also has the ports, but these ports in the switch connects to a device, a chip called ASIC. Application specific integrated circuits. Application specific integrated circuit. This is inside the switch. Now this ASIC has the ability to remember, store, and forward, right? There are also two types. So when we'll discuss the switch, we can discuss these things. But just to know, let it be. So it is hub here written, but it can be a switch as well. All right, you can see, so it is a star formation here inside the switch. So if your device is connected here, sorry, if your device connected here and you want to send information to the device connected here, so this will come to this port, it will go to the ASIC, ASIC will decide, check, and then it will forward to here. But hub was not this much, it was just connected with each other. Okay, so star topology, what happens, a centralized device is connected, and from this device, all the endpoints are getting connected. This kind of cable, the twisted pair cable, if you go to office, this cable you see with RJ45 connector, you connect it to your laptops or computers to get the connection. Okay, so this is being used, and it has more ability, 100 Mbps, 1000 Mbps speed. Troubleshooting is very easy, because anything happens to this computer, it will be this part, and it will be this centralized device, which is which can be checked upon. Okay, so nowadays or any day you will get this topology in place. It is still being used. Okay. Ring topology, this is also you will not see anywhere. It is a legacy technology. What was happening there, any kind of cable if you take, but it was connected to the devices like a ring, right? So this is device 4. These are the end devices which are connected in a ring, and this was like only clockwise transmission. Okay, there was a 3 bytes frame which is called a token, which was revolving to the device, which was in the network passing through. So whenever if device 5 wants to send the data to device 1, device 5 has to freeze that token. It will have the token. The token is the permission to transmit the data. Now device will send the data to device 1. Okay, and once the device 1 get the data, so what will device 5 do? Device 5 will create a frame. It will have sender, it will have receiver, and it will send to device 6 in between. Now device 6 will check the address. If this data is for me, no, he will send to device 1. Device will be check, here is the my address. Yes, it was my address in the receiver. So it will accept the data and it will send the acknowledgement. Yes, I got the data. It will now free the token. Token is free. Token is now revolving around in the network. Somebody else wants to transfer something. So one time, one device with one token can transfer in the ring to any device. So the problem was, if this device is down and this device wants to talk to this one, it will not be able to, because it cannot go by this way. So not practical. It was used, but never got so famous or so widely known. But still. So another thing, in ring topology, what was happening? This was a multi-access unit. This device was there in the between, right? And these are the ports. So this is the logical example of what was happening, and this is the practical how it was used. Like in star, you saw that one central device was there. Everybody was connected to this central device. Everybody, right? And in switch also, all the devices, all the ports were getting to one central epic. So it was a star formation. But in in MAU multi-access unit, in this device, what is happening? It is port 1, port 2, port 3, port 4. The devices are connected here. But this was internally, it was connected to this one, like this. Okay, this was forming a ring. This is also not used. Then came, there is a topology called free topology. How it works? Suppose there are large network. One floor is here. There is a switch. There are computers connected. One floor is there. Computers connected. Other floor is here. There is also computers connected with a switch. There are computer connected with the switch. These computers need to be connected to each other, right? So what was happening? There was a switch here. So there was a switch. Here is also a switch, which is connecting these two, which is connecting these two. There is a switch which is connecting these two. So these two are connected, but these are not connected to each other. For this, what we can do, we can purchase another switch, which is a high-end switch. We can connect to this like this. So anywhere from this computer, suppose this is 1 and this is 14. If one wants to communicate to 14, it will go to this switch here, like this. This will go to this switch. This will go to this switch. And this switch will communicate to here. Okay. So this is also in use. And this is like the troubleshooting is easy. How? Because if this device is not working, so you will see the switch connected to this device only. You will not go to this main switch or main terminal. Okay, you'll have to check till this one. So troubleshooting becomes easy for this one. So this is also being used in a market. There's another topology which is called mesh. So mesh is for wide area networks. It is not for local area networks like we have in our small office, in our offices in a building. So we don't have this. Well, actually, what happens in mesh? Suppose there is a office here. There is a switch here. It has devices connected. And this location is Gurgaon. Okay. There is another device here. There are n devices connected here. People are working. This location is Mumbai. There is another devices here. People are working. Servers are there. Endpoints are get connected. This is Bangalore. Now, Gurgaon office is also connected to one of the ISPs. This office is also connected to ISP. ISP, I mean Airtel, Airtel, Geo, whatever it is, it takes. Okay. So how it will show you, and this is also connected to ISP, and ISPs are connected to each other. This is also connected. Okay. So if ISP is here, ISP is here, ISP is here, ISP is here. So these are all connected. So this is mesh. Mostly fiber optic cables are used because in internal network, in local area network, there are a few data transmissions which is being done. The transmissions are not very much, but in the wide area network, so the transmission, the data are very vast. So these devices, these cables, these uh, fiber optic cables, these are fast, and uh, obviously these are costly because these are fast and these are high-end. This can support high-end devices with high speed. These are being used in ISP. And what is multipath for communication? So suppose there is some issue with any computer connected to this ISP, but this ISP has multiple paths to get to this ISP. It can get from here, from here. If there is a fiber cut or line connection is down from here, it will have this path always working. So that is why it is called multipath for communication. All right. Another is hybrid technology. It is very simple combination of two or more topologies as per the needs. Okay. Wherever we have LAN, we can use star topology. And wherever we have the wide area network or the data communication is fast, or we want to connect two branches, we are using mesh, or I think this is an example of bus and star. So if it is being used as per the convenience, think about cost effective, so we can talk at hybrid topology. So nowadays you will get star, free, hybrid, mesh. Free is also not very prevalent. So you'll get these three. Okay, so if you are working in a corporate scenario, if you are working with one of the ISPs, so still you will not be able to troubleshoot the mesh because mesh is something with the connection of various paths. So whenever you will work, there would be fiber cut in one of the path. You'll work for one path only. So this is just to understand how these are connected. Okay. All right. So this was about topologies. So I'm open for questions and feedbacks. If I need to tweak something, or do you want something else? So I'm open for these things. Please.
Yes, guys, you can ask your doubts and we can sum up after that.
As of now, no. Thank you.
Thank you.
Yeah, thank you.
Thank you so much. Then let's meet in next class.
Yes, yes, sir. Let's connect by tomorrow, same time. And today's session was also like very nice and very informative. And let's meet tomorrow, 9 p.m. Thank you, everyone. Thank you, sir.
Thank you. Thank you so much. Have
Thank
a
you.
great day,
Thank
guys.
you.
Bye.
Yeah.
Good night.